Now, here it goes. There we go.
All right.
Oh, yeah. So.
Lights, action, cameras. Every one of us has microphones and cameras. Welcome aboard. We're going to do it again. Number 12, everybody. Welcome aboard the SBAU Astro Hour for your local Santa Barbara-based long-term astronomy and telescope club. I'm proud to be in it. In fact, I hold down an office. My name's Baron Ron Herron. For the next hour, we're going to do space news, discoveries, landing on other planets nearby. It is, as I say, episode number 12. We've been doing 12 of these on Monday mornings, 11 a.m. Series 1 would be 2021, and it's for the Astronomical Unit, SBAU.org, if you want to join us. So for the next hour, we're on YouTube, and they're archived. Let me introduce you to my good friends, many on the board, who are ladies and gentlemen. I call the Brain Trust President, Jerry Wilson. How you doing, young man?
Good
you
morning.
haven't thrown away your masks yet, have you?
No.
Okay. Are you getting any time with your telescope at night around here? No. Okay. Well, we'll talk about that. Uh-oh, there's sirens outside, but then again, we found out you can't hear other noises. Chuck McPartland, our outreach coordinator.
Good morning.
We'll be talking about with you this hour about DIY, do-it-yourself outreach involving the ISS. It's every night now, isn't it?
It's making a lot of passes, yeah.
Okay.
They're not all real good this week, but they were good. There was a real good one Saturday.
Well, we're going to get so used to it. I got some definite questions about it. I'm curious about how we can even see it, that far away. Can you see a bus 200 miles away in Salinas if you could get up high enough? I don't think so.
If the sun's shining on it and it's covered with reflective foil, you probably could.
So, okay.
Well, you go to Google Earth and you can see buses, you can see cars.
Oh, no kidding. Well, that's true.
You go to images.
Yeah, you're right. That would be Bruce Murdoch, one of our stalwart members and the man behind, I guess, the Santa Barbara Theater Organ Society. Your microphone's fixed this week. Thank you and welcome aboard.
I can make it louder.
Yeah, our wizard behind getting us on the air is our webmaster in the upper left picture of the 6 on the screen, ladies and gentlemen, Tom Totten, who was a past president, and then joining us from his kitchen or somewhere. I smell bread. I'm sorry. Every week, it's the bread baker and the former teacher, science beloved professor. I call him a professor, Tom Whittemore. He gets embarrassed when I say that. Welcome aboard, Thomas.
Morning. Thanks.
How's Maureen? All the wives are doing fine, and we're ready to hit those restaurants full time. Here are the main headlines of the week we're going to talk about this hour. And anybody who wants to post a comment, Totten, what is that at the bottom right? Comment section, YouTube.
It should be on. If you go to YouTube and you're playing us live, there's three watching us right now, including myself. It's on the right-hand side. There's a chat there, so people can talk there. Put in their comments. And
occasionally you get emails from Tim Crawford or others in the club during the program here. China landed their Tianwen on Mars. They are also orbiting the moon, and they're on the other side of the moon at a strange burnout way of landing we'll talk about. 3 images of Jupiter have been posted. President Jerry will tell us about that. And Chuck, as we talked about, is monitoring nightly viewings, I guess, of that incredible 17,000 mile an hour. How high up is it, Chuck?
About 225 miles, something like that.
That's a long way away, but we'll talk about it. Mr. President, what's your pleasure? Kick this off.
Jerry? Start at the top.
All right, let me bring you what I learned. They landed Friday, did they not, on Mars?
Oh, start there. Okay.
Yeah, China. I mean, we're in the scientific border community. There's no borders with us.
Right.
So whatever they discover, and they're going to be doing a lot. The United Arab Emirates are also there, but orbiting Mars, and they're not going to land, right?
They have no plans to land. China is the second people to successfully land an operating satellite on Mars, the second country besides the US. Russia has tried a number of times, but not got there.
Oh, Russia seems to own Venus, though, don't they?
From earlier era, yes. Yeah.
Yeah, they gave up on that. Well, one of the things we're going to talk about is the descent strategy they used, which I think I understand. They landed in what's called Utopia Planitia. And it's the Tianwen one. That's the whole caboodle, if you will, and the one that rolls off the platform after they landed it. You're going to have to discuss it and tell us how they did it. Different from the way we landed Perseverance, right, Jerry?
Yeah. If you
How
can
did
show
they- how
that.
did-
Oh, yeah. Tom's got the picture up there for it.
Oh, yeah.
The blue line starting from upper left is the whole package, the orbiter and the lander and the rover, all as a single package. They fired a retro rocket and deorbited it and sent the entire package on a trajectory to the landing spot they wanted. And then while they were on that landing trajectory, they ejected the lander and the rover. And then the orbiter refired its rockets and went back up. That's the green line going up. They went back up into orbit, and the lander and the rover continued on down through the stages similar to what we do. They have the parachute, the high-speed drogue chutes that slow it down, and then they fire retro rockets for the final landing. They did not use a sky crane like we do, where the thing that has the rockets on it, the retro rockets, where it lowers the craft, the lander down on cables. And then when they let go, it flies off. This one, the whole thing landed.
So the whole thing has rockets on it
Yeah,
underneath.
the whole thing does. And then the rover then will drive off of the lander.
The rover is called Herron, and it's now off of it. As far as you know, it was Friday, sometime in the middle of the night, I guess, that
I
they
don't know if
landed.
they've
They had
driven
their,
off yet.
Yeah,
oh, it hasn't driven off.
they didn't,
But,
in the article I read, they didn't make a statement yet about the plans when they would drive off or if they have done it.
An interesting phrase I keep hearing is 7 minutes of terror, where they can't do a dang thing. That's how long it takes. That's the going rate of landing on Mars, 7 minutes.
That's from that top dotted line you see there when the aeroshell hits the atmosphere,
Right?
until they actually slow down enough and the parachute slowed them down enough that they don't have an ionization shell around them where they can't talk through it.
Okay.
And,
boy,
they could only talk to the orbiter, and it would still take 18 minutes for a signal to end up at the Earth. So basically it's 7 minutes of they can't do anything. They hope
But
it
now-
works.
in that special descent, that the early parts of it that Jerry was describing, is the original part that belched it out still in orbit? It's just
Yeah.
going to do anything more?
That's the green line when it went back up above, and it has other instruments, and it's got the relay to the Earth for talking to the lander.
Okay. But it's not going to go back to Earth or anything like that. It's just going
No,
to stay in
no.
orbit. So
In
that's-
orbit of Mars.
That's where it is. We're going to start polluting the sky above Mars like we do here. Here's
It's only
my
43 minutes where they can't do anything, because it's 36 minutes to send something to Earth and have Earth respond.
Yeah.
And then you have the 7 minutes on top of that.
Yeah.
Well, we certainly had one when NASA landed. JPL was in control. Those people held their breath for about 7 minutes and finally got the word out. But Mars is on the other side, isn't it?
Yep.
So it's even further. What if they were right next to us in the next orbit out? How long? That's a little less time, isn't it, for radio waves?
36 million miles. That would be 2.5, 3 minutes or something like that.
Okay, but now it's taken even longer than to go to the sun and back. It's past 93 million, isn't it? It's on the other side, as we said.
Twice that, yeah.
Here's
Twice that.
Here's my stupid question of the week. No oxygen, right, in the thin air of Mars. So you would never see anything flame out, catch fire coming in. What would it do? Just smoke?
Low probability of a fire.
Okay, if you were on Mars, you'd
No
never see
oxygen.
meteors.
Sure you
Oh,
would.
no, that's just heat. That's not a flame.
Yeah,
Oh.
that's light, Ron. When something heats up, it gives off light. It's like fluorescence. And so
Okay,
that's what you're seeing in a flame. And you'd also see that. It doesn't mean that there's oxygen burning. It just means that something is hot.
okay. But the fact that things do catch fire coming into our atmosphere gives us a little additional light show, wouldn't you say, than you'd see on other planets that might have.
Possibly.
Yeah,
Okay.
maybe. The basically everything on Mars that can burn already has, because the red planet is basically red because of iron oxide. So its oxygen is combined with iron on the surface, and that's why you see it as red.
Is that right?
Yeah.
Wow. Well, can you remember some of the things that I remember basically about what it's going to do, the Zhurong or the whole Tianwen thing? It can look down into the surface like 300 feet, 100 meters.
I think
Yeah,
Ground penetrating radar.
Right.
okay. What else is it going to do? You remember any of the things that it's equipped with?
It's got a camera. It's got a laser for doing spectroscopy.
And it's going to last 3 months.
That's the planned amount that it'll last, but that was also the planned amount that Opportunity and Spirit were going to last, and they lasted for years.
Okay, so at least 90 sols. That's what the Martian day is called, a SOL. And it's pretty close to our day, isn't it? It's a little longer by 20 minutes or something.
48 minutes, I think, longer.
Oh, is it? Okay. Well, let's catch up before we have Tom Whittemore do his report on tectonics on Mars with Perseverance. First of all, are there 5 E's in that word? I think there are, aren't there? If you write it down. How's it doing? The helicopter is front and center. It's done all it's going to do, but now they're going to continue sending it out. Did it go up over the weekend? It did.
I haven't heard whether it went up, but they're going to start using it to scout ahead for where they want to go. It lets them, peek ahead of their terrain and start planning farther ahead than they would otherwise.
Okay, so if the rover, which is Perseverance, follows it or goes where it's mapped out or scouted a place, it'll just land at a new spot nearby, wherever the rover ends up.
It already has flown to a new place from where it initially lifted off from.
I gotcha. And does it go any higher than 20 feet or so? I think that's about, there it is. There's the picture. Thanks, Tom.
That's the highest I've heard.
Okay. I wonder why we didn't get any pictures this past weekend. Maybe they just didn't release them. It's all JPL, isn't it?
Yeah, you can go to the webpage and get them practically as they arrive.
Wow. What is that? What is that webpage? JPL.org?
This one you're looking at, you need this red and green filtered lenses on your eyes to see this picture.
Incidentally, that was a great.
Go ahead, Chuck.
Well, I think it's just mars.nasa.gov or something like that, where you can eventually get to the Perseverance mission.
I gotcha. So it wasn't just doomed for 90 days or 90 sols, was it? It was, they plan on having that sucker on there for years, like Curiosity and the others.
They'll use it till it quits.
Yeah.
Okay.
The nominal mission may only be 1 year or something like that, or 2 years, but they'll run it as long as it will go.
Do you suppose the Zhurong is going to try to find Viking 2?
No, it's too far to go.
Oh, it is. We'll never land on the poles of Mars, will we? The reason I'm thinking is that to get sunlight directly on their solar panels.
Well, Mars has a tilt similar to ours, so they will have sunlight at their north and south poles. But they'll go through, longer seasons than we do here on Earth. And we've landed up close to at higher latitudes with the one mission, Phoenix, I think it was, that was looking for water ice.
Yeah.
Did they find any?
Oh, yeah. They landed on some, basically.
Yeah.
Ice right there on the surface.
Well, no, it was under the dirt, but it was only a thin covering of dirt.
Yeah. The rovers up there now have run on nuclear power. They don't need solar panels.
Oh, is that right?
Yeah, Perseverance and Curiosity and whatever the other one is.
I swear I see them, though they do have solar powers. I guess it helps.
No,
they're gone.
No, they don't have solar panels. It's the older ones, Spirit and Opportunity, and the Zhurong, the Chinese one.
So Zhurong doesn't have nuclear, as far as we know. It's dealing with what, a third less sunlight than we get here on Earth.
About half of what we have.
Now, Whittemore, you brought this up last week, and I think we were talking about the Drake equation, about the likelihood of life on other planets and whatnot. And we talked about tectonics, and I believe you made the statement, did you not, that plate tectonics would be necessary for life to evolve anywhere?
No, I wouldn't be that definitive. I'd say that it is possible that plate tectonics, because it's a carbon regenerator, okay, could be part of the package for the maintenance of life on a planet that decides to make life. Okay, and the thing I referenced was on January the 16th, Science News had a great article. Okay, the particular issue is called Restless Earth, and the main article in there is about, it's a really good history of tectonics if you want to brush up on tectonics and how long it took people really to accept this. Okay, it's kind of, I mean, some people in this article said that it was the most major advance since general relativity, okay, in the world of geology. But inside of that article, inside of the history of plate tectonics is a beautiful little article, and that's the one I sent to Jerry. Jerry, I just sent you the middle one, okay, and it's written by Carolyn Gramling, and she really covers the earth science for Science News. It was called Crucible of Life, okay? And what she does is she presents some arguments from a professor at Arizona State, okay, at Arizona State, it's woman, that maybe to get life to prosper, a planet would need plate tectonics, okay? If I may, I just read a really short,
We're losing
okay,
you.
that pull it together in full of life article here. Yeah, go ahead. Okay. We know plate tectonics plays a powerful role in keeping Earth habitable, primarily by moving carbon around. It's responsible for mediating the climate on long geological timescales, making sure the climate is more or less temperate for life, says Roger Fu, a geophysicist at Harvard University. Just another little paragraph here. When two tectonic plates collide, one can slide beneath the other, carrying rocks bearing carbon deep into the planet's interior. The subducting plate begins to melt and volcanoes bloom on the overlying plate, belching carbon dioxide and other gases into the atmosphere. As carbon dioxide builds up, it warms the planet through the greenhouse effect. And so what this lady talks about, this professor talks about, is this beautiful cycle of the maintenance of sort of conditions that would make, would enhance, if life gets going, that it just prospers, it just stays. It's a really, really, really good article. And I highly recommend it for people. If one, you just want to brush up on your plate tectonics, it's a great little history package. And also this idea. So Gramling does not argue that it's necessary, but she says basically that, you know, it's a pretty good condition for the maintenance of life once it starts. Okay. And to be honest, nobody really knows quite when plate tectonics started on the Earth. Okay. Okay. And in fact, it could be that life was already here and the plate tectonics just basically enhanced the capability of prospering. So that's all I really wanted to say about that. It's a real short article right in the middle of the main article. It's just really neat. And it gets you thinking. It gets you thinking, you know?
Yes. Let me add a comment. When I was in school in the 1950s, we were in a class in geography. And we noticed that the eastern coastline of South America and the western coastline of Africa tended to fit together. But the teacher assured us that despite that, the continents never were actually together.
Really?
So the plate tectonics was developed or came to be accepted after that in the 60s, somewhere, I would guess. Or else this teacher needed to go back and refresh her geology.
Even though in the late 1800s, I think it was, you had paleontologists who found fossils and fossil beds that matched, you know, between Brazil and Africa.
Yeah.
Well, the content in the Norwegian mountains are very similar to the ones in Appalachia, in those mountains. Very similar.
Yeah, there's a lot of evidence once you know what to look for. The other thing that I've always been curious about is the origin of the moon, which I guess the accepted theory is that the proto-Earth was hit by a planet about Mars size, which we label as Theia. And I was wondering if that resulted in a very thin crust on the Earth. And that's one of the things that led to the plate tectonics that we have. And so in the past, maybe a planet has to undergo some trauma to have a surface or a crust layer that's capable of plate tectonics.
Yep.
Just a speculation and a question. Not
Yeah, yeah.
Well,
Yeah,
we
it's
know there,
this wonderful article. It really gets you thinking,
Yeah.
the necessity. Yeah.
we have 7 continents, do we not? Is that how many? Do we have the plate tectonics nailed down as far as their shape and size and the number of them?
Yeah, we
Yeah.
can see all the cracks and map them.
Right.
They started off as Gondwanaland, right?
Well, that was
Yeah,
when
a
a lot of them were together.
Yeah.
I think there's more plates than continents.
Yeah.
Oh,
Yeah, I think that's correct, Jerry.
because the
Yeah,
ocean.
Well, there's multiple plates in the Pacific.
Yeah.
Yeah. But at one time, Western Africa wasn't hooked on to South America, as you said.
Oh,
They looked.
apparently it was.
Oh, it
Yeah.
was.
Yeah.
Mhm.
And that was
Yeah.
Gondwana, or
Gondwanaland.
That was a much earlier era. Right
Yeah.
now, there's in the triangle, the Afar Triangle on Eastern Africa.
right?
That is a continental rift that is opening up. Soon that will fill with water, and then that will become a sea as it moves apart. And also in Iceland, North America and European plates are moving apart. You can go stand down in, and I even saw a picture this week of a diver diving into one of these rifts, and he was touching two sides of I've extended my hands. He was touching the two sides of the walls he was in a scuba gear, and he was touching 2 different continents because he was in a rift that was opening up. I think it was in Iceland.
Well, I'm thinking, gentlemen, that since we see the dinosaur bones, they're still here, that this subduction thing is really slower than evolution, I would hope, or they'd all be gone, wouldn't they? Do you know what I'm saying here?
Yeah.
Yes.
Okay.
I've
Now,
also, and in that vein, I've also heard that the reason that birds migrate over major portions of the Earth's circumference is due to the gradual continental shift, that they just keep incrementally extending their range and learning it. I don't know if that's true or not. Someone told me that, but I don't know. It's believable.
this land we're sitting on in our houses is moving like what, a couple centimeters a year? Is that?
Yeah. Something like that.
Mhm.
Now, how about on Mars? Is there a active volcano?
There's evidence for a currently active volcano. There are plenty of old volcanoes too.
Well, I know, but active conjures up a thought of smoke coming out, wouldn't
Or
it?
lava moving, magma moving.
Well, why wouldn't we want to land a lander there nearby?
We probably
Information.
will.
It's not Olympus Mons, is it?
It's probably in the region where Olympus Mons is, because that
That's
seems
what-
to be the most active.
Yeah, for the benefit of the listeners that don't know, or the viewers, that's one high mountain, that Olympus Mons, isn't it?
Mhm.
Like 3 times higher than Mount Everest.
Good Lord.
Yeah, it's really tall.
Lower
And they-
gravity. But
and they
there's
think-
also periodically there's methane released into the atmosphere, which people speculate may be due to some bacterial life form, but it also may be due to volcanism.
Okay, but Tom Whittemore, are there
Yeah.
plate tectonics therefore on Mars?
No, Mars has a really singular crust.
Right.
It's thick and it's unitary. There's a big crack there that's Valles Marineris, and that's when, as it cooled, it shrank and things weren't fitting anymore, and it kind of cracked open there.
Okay, is Mars's mantle or crust thicker than the Earth's?
The crust is thicker, we
Okay.
think.
So to get a volcano, it has to break through quite a ways, I would imagine.
Right. But
Even
there
though
are
it's
cracks because of the shrinking.
wonder how many people know that Mars is about what, 2/3 of our diameter and about half our size, just a little bigger than the
Half our
moon.
mass.
Yeah,
It's
look at
like
these
half the
pic-
diameter and 1/10 the mass.
Oh, 1/10 the mass.
Yeah.
It's a lightweight.
Well, I've heard that about Saturn, that it would float in a big tub.
Yeah.
Never about
But it would
Mars.
leave a ring.
Yeah.
Well, what do you suppose the Chinese are going to look for in sonaring down 100 meters? What are they going to find?
They're probably
Rock, or
looking
what
for
are they-
ice.
Oh, that reflects back.
Yeah.
Okay.
reflects differently anyway.
Okay, well, all that water that used to they think was on Mars is mostly gone. What's left is frozen little ponds underneath.
The current theory that I read a couple weeks ago, for the first time, it's proposed that most of the water is actually still there. It's subducted into the interior of Mars and left the surface dry. It's in contrast to the Earth, where because we have plate tectonics, the water cycles back up to the surface on the Earth. On Mars, there's no plate tectonics to recycle the water back up to the surface. So it's mostly still there.
Does it ever get warmer than our 32 degrees, the freezing point of water?
Yes.
It does?
Yeah, there's spots that are, it can be up to 70 degrees in the summertime.
Yes, yes.
Wow.
Only briefly, though.
And that doesn't take into effect the wind chill.
Yeah.
Wind chill with 1% of our atmosphere, there's a wind chill.
I'm joking.
Oh, well, there's dust devils. Why could there be a wind chill? Have you also heard, gentlemen, about strange looking empty tubes, like long barreled caves on Mars, where I guess lava flowed?
Yeah.
And the moon and Hawaii, you can see them.
Okay, interesting.
I walked through one.
Great report, Tom Whittemore. What's your thought on it? Huh?
Yeah, I just encourage people to, find this article on the web. It's, you can grab it. It's really good. Again, it's from the Science News January 16th issue this year. Okay.
Incidentally, speaking of websites and whatnot, Mr. President, I regretfully have to ask you again because I didn't write it down. Where do we get the Monday, Tuesday, Wednesday, Thursday, Friday night sky? Is that Astronomy Magazine?
Yeah, they're based on what Astronomy Magazine calls the Sky This Week, I think it is.
Okay, but
I'm glad you're improving on their star maps, though.
Oh, those, I add the star maps.
Yeah.
That's not there.
Yeah, theirs are pretty bad.
Yeah.
Well, let's see. You want to cover quickly Monday tonight? You were
Right.
talking earlier about
there it is. Thanks, Tom.
what?
There's the issue.
Oh, there's the issue. Science News, Restless Earth.
Yeah.
Fascinating.
Comes out
stuff.
twice a month.
I used to be worried about plate tectonics, but now I guess I feel a little better about it. Keeps us going here.
Hey, Baron, I want to interrupt you, Baron, because Tim Crawford's asking a few questions. He's wondering about Mars and the plate tectonics, and he's wondering if there's any kind of relation to why Mars' atmosphere is mostly gone and the core being solid or fluid, and also about Mars' magnetic field, of which I don't think there is any on Mars. Any other comments on that?
There's not much magnetic field on Mars. There are some relic fields that they've found where they're kind of frozen into the rocks, kind of like on the moon. But there's currently not a really active dynamo down there. We don't think the magma is really moving around like it is here to generate the magnetic field.
And that's why Mars' atmosphere also gets pounded by the sun, because there's not like a magnetic shield around Mars, or a very weak one.
Yep.
But it does tilt like the Earth, but not as much.
Yeah.
A little bit more, actually.
No, it's 26 degrees.
Yeah.
Yeah, it's close to the Earth.
Oh, it
Very
is.
close.
Yeah.
Does that have anything to do with the electromagnetic field around the Earth? It doesn't.
No.
Bruce, you have any comment on all of this?
No, not particularly. I
Well,
understand it.
okay. Interesting stuff. Good to know that Crazy Tim Crawford is back with us. Tomorrow night is his night, isn't it, Tom Totten?
Telescope workshop. Yeah, maybe we'll hear a little bit more about his 8-inch mirror.
Again.
SBAU.org would get us on board if somebody wanted to join, right? You have as many as 12 people, including Mr. President there. Let's let me do one real quick, silly, and then we'll get to the ISS overpasses. Gentlemen, I thought of this, and I'm going to offer 10 years extra on your life for the first person that can tell me on our podcast the 2 words that are on our official white SBAU bumper stickers that we put on our cars years ago. Who knows those 2 words?
Tim made several of those.
Yeah.
Dark matters.
Dark matters.
That's one of them. The other one is "Come see the sky with us."
Yeah.
Oh, that one I didn't see. I got dark matters, and Good old dark.
Well, Tim had a
Ron,
bunch of
Not
bumper
dark enough
stickers
for
made
us,
up
though.
of
That overcast kind of lightens the sky. Listen, Mr. Murdoch, you want to tell us real quickly what's going on with the Theater Organ Society? Did you get to your special pandemic
Arlington,
of something you were going to do in spring?
well, the Arlington
What?
is opening up for movies. They're starting on the Friday the 21st. They're showing older movies. I forgot what the movie is on the 21st.
Okay.
On the 22nd, it's Ghostbusters 1, and we'll have a live theater pipe organist playing for the intermission there, Adam Aceto. Tickets are $5, and so
Okay.
it should be a good time.
Okay. All right. You keep reminding us about that. Now, Chuck, the last time you did an outreach was online, virtual, but you're telling everybody they can do their own looking for the station international, right? Going over now that they got a change of astronauts. Is it every
You need
night
to have a good sky, though.
these days?
Well, it's going over tonight and on the 18th and the 19th, but the passes on the 18th and 19th are very low skimmers, so they're not going to be very visible. But tonight, it rises around 8:46. That's when it gets 10 degrees up in the west-southwest, and it passes kind of. Is this our pass for tonight? Yeah. Okay.
It's a second pass or something.
Well, it's magnitude 1.9. I only have one pass in there. And west-southwest to north-northeast, that doesn't look like it.
Okay.
Because that's starting early. Is this the ISS?
ISS.
Okay, they may have changed their orbit since I got this. What's the ground location?
I've got Goleta.
Okay. All right, so they may have changed their orbit a little bit. I mean, I had it starting in the west-southwest, going to the north-northeast, basically from about where Capella is over to where Deneb is.
Well, this is really early in the morning.
That's an early morning pass. Yeah, I'm only doing evening passes usually. So the minus 1.9 one there, yeah. Okay, there we go. So it's starting over there by where Sirius is setting, and it works its way kind of at a medium height across by Capella. You can see Venus and Mercury there in the right-hand side, and then it continues over through all the dim stuff. You know, the Camelopardalis is actually the giraffe, the spotted camel, and then over between Polaris and Cepheus, and setting over there by where Vega is going to rise. So it'll be a decent pass, but that's really the only one this week. After that, they're really very low kind of mountain skimmers, and it'll be hard to see.
Okay. They'll also be hard to see from our area because of the marine layer.
Yeah, the marine layer is supposed to kind of start going away. I know that I have an occultation early Wednesday morning, and it's supposed to be clear Tuesday night and Wednesday. So we might have it again tonight, and then it will clear out.
Good.
Do we know the names of either the asteroid or the star you're going to occult?
The asteroid's called Albina, and it's like a 90% probability from here, so that should be pretty good.
90%.
It's a dim target star, so that'll cause some fun.
Okay. More dumb questions from your host. Is it only early evening, not long after sunset, or early morning, not long before sunrise, that we can see the ISS? Because it would pick up sunlight. Middle of the night, we're not going to see it, are we?
Right. Although as we get toward the solstice, as we get toward June, it can be visible quite late in the evening.
Mm-hmm.
Really?
Good question, though.
Yeah.
Yeah.
Well, now, a week or so ago, everybody was reporting the string of lights in the sky. Those were freshly launched multiple satellites, right?
Starlink satellites.
Okay. Are they long gone? Are we going to see those in formation again?
If you work at it, they're getting in gradually higher orbits, so they get dimmer and dimmer. If you were taking an astrophoto, they'd still show, but if you're trying to look at them visually, you probably want binoculars. Although some of them are still magnitude 2.5, so they're like a little dimmer than Polaris, so they'd be visible if you knew right where to look. And you can see those on Heavens Above also.
Okay, but we know up there surrounding the Earth or orbiting the Earth are just godzillions of things, junk. Is the space station one of the largest, and that's why we can
Yeah.
see it? Everything else is relatively small, size of a
Compared to
car
the
or less?
station, yeah.
Yeah.
Okay.
These pictures are from Mike Chibnik up in Rio Vista, a member of our club.
Oh, does he ever come down here?
Yeah, on occasion.
I wonder if I met him. Has he ever come to one of our Friday meetings?
Oh, yeah. Been
Oh,
to a lot of them.
Yeah. He used to
okay.
come to the workshop too.
He's
Will
the
we-
former president of the Ventura Astronomical Club.
Okay. I remember his name came up last week, and there was
Yeah.
somebody else involved with that. All right. You want to talk about Mercury in the sky tonight? Anybody? Jerry? Chuck?
It's at its highest for this apparition. So it's going to be at 7:50, so 10 minutes to 8 tonight. If we don't get the May gray, it's going to be at its highest, like 21 degrees up.
Okay.
And then Venus will be really bright and about 8 degrees below it.
Tom, could you show the picture I supplied for this? For the
Okay, hold
first-
on.
Okay.
But another interesting thing about it is the Mercury doesn't have much of a magnetic field, and it's getting blasted by the solar wind. And so it has a tail of sodium ions that come off of it. And with the relative positions of Mercury and the sun and us right now, that tail is kind of blasting out from it and being illuminated by the sun, so it's easy to see. And if you have a special sodium filter that passes only the yellow light, it's a lot easier to see. But you can also see it if you take a series of exposures. And if
That's it.
on heavensabove.com, you can see some of the pictures. And
Mhm.
it's like a bunch of 30-second at ISO 3200 images stacked together. And you can actually see that Mercury has a tail, just like it's a comet.
High sodium.
Well, that happens to be easily ionized and easily pushed off the surface. So it glows in yellow light that's easy for us to see, comes through the atmosphere well.
Hmm.
So this
Yeah, but
shows our western horizon just after sunset, about 8 o'clock in the evening. You can see Mercury up above in red letters and Venus down below in white.
Well,
And it's in Taurus the bull.
Yeah, and
Right.
Venus is quite bright.
Yeah.
Very bright. And last night I saw Mercury well after 9. You know.
is that right? With a clear sky, Tom?
Yeah, we had clear sky here in the west for a little bit. Yeah. Mhm.
Well, speaking of the tail, you mentioned a new comet. I think it was among your notes, Jerry. Temple. Is that the name of a comet?
Yeah, Tom, could you show the morning sky?
All right.
Temple's not going to be particularly a new comet, but one that's returning.
Right.
Temple. It's called Temple.
Yeah.
Temple.
Is that named after somebody? Some
Oh,
Yeah.
you just passed it.
astronomer.
There you go.
Oh, there. Okay, that's Uranus or Neptune.
That's Neptune up above and Uranus down, and yeah. The
Wow.
thing with the red circles around it, that's the comet Temple, and the info on that is in the white legend at the lower left.
So
This is
those.
this is planetarium software at 6 a.m. tomorrow morning.
Oh, okay, for Tuesday.
Yeah.
Neptune rises before dawn in Aquarius. And I assume whenever we can see Neptune or Uranus, obviously they got to be on this side of the sun. We'd never see them on the other side.
Oh,
No,
no.
we see them on the other side.
I guess they get a little more light, don't they? But it's still farther away from us.
We
Over
see
here.
them when
Well-
they rise at sunset and set at sunrise, then they're opposite the sun, and we see them as their full illumination.
And then
But
tomorrow night,
they're, Ron, they're so far away that their relative distance doesn't change all that
Right.
much to us.
oh, yeah, you're probably right. Yeah, well, they're way out there, aren't
In
they? How
in
many?
fact, you know how we had that trick question at the Christmas party a couple of years ago about which planet is closest to the Earth most of the time, and it's Mercury, and it's actually the closest planet to all the other planets most of the time because, because it has such a fast orbit. I wanted to warn people with this comet here, people who have Sky Safari, it's kind of going away now, but the last couple of weeks, they'll see a comet on there called Brorson. And it looked like it was getting super bright. And I'm sure people were going out and wondering why they couldn't see it. It turns out it's a comet that was seen decades ago and lost. And they think it broke up and just evaporated. but the orbital elements are still in
Oh,
the system. And so when Sky Safari downloads it, it looks at the orbital elements and it looks at the brightness it had decades ago, and it tries to compute a brightness that it would have at its current distance from the sun if it were still in that same orbit. And so it's been putting up this comet Brorson in the software on the screen for people saying, hey, here's a bright comet to go look for. And it actually isn't there.
Well, bring it up, the ionized, what did you call it again, off of Mercury?
Sodium trail, yeah.
It doesn't look like a comet. You can't see that trail, can you?
If you take a photograph and then stack them, a bunch of photographs, yeah, then you can see it.
yeah. If you enhance the photo, you can pick it out.
Is that always happening with Mercury, or just
Yep.
now is there a burst of sun stuff?
Well, it's a favorable positioning as far as the direction. The tail is always pointing away from the sun.
Yeah,
And because of the relative positions of our planets now, it's easiest to see.
I see. Interesting.
Now, because Neptune is mentioned as being in the morning sky, I added a couple pictures of Neptune that
Well,
shows
its interior.
what the center is like,
Here they
and
come.
its size in relationship to the Earth.
The only blemish is a white spot in the middle, a bunch of white clouds. What is that?
Yeah, you can see these storms
Yep.
on Neptune periodically.
It's also got a spot
Like where? Where's the spot?
right where the clouds are.
Oh, well, that doesn't, it's not
The
shaped
white
like
borders the blue spot.
we saw something like that up in the atmosphere of Mars. It had something like
Oh
a
yeah, we
cloud.
saw some thin clouds up there. These are very different clouds. I don't know if these are water.
Otherwise, water could be in the middle of all that blue ball, several hundred
Well,
thousand miles down.
You show yeah, so
There it is.
the number one is the upper atmospheric clouds in there. Number
Right.
two is the atmosphere consisting of hydrogen, helium, and methane gas. And number three is the mantle consisting of water, ammonia, and methane ices. That's why this is called an ice giant. And the core consisting of rock, silicates, and nickel iron. And they get
Wow.
these profiles for the planets by plotting the motion, the gravitational effect of the planet on a probe as it goes by. You can figure out the mass distribution in there, and from that, you can figure out the density and what it's likely to be.
So it's warmer inside than it is outside.
Yes, in fact, it radiates away more energy than it receives from the sun.
Wow.
And
They-
it's also got the fastest winds in the solar system found so far, something like 1,200-mile-an-hour winds.
Oh, God, yeah. Jeez. So that little white blemish we saw earlier, what was it? That's a storm on a place that has 1,200-mile-an-hour winds anyway? That's
Yeah.
nothing but one big storm, I would think.
It's all relative.
Yeah. Well, that is Wednesday. Wait a minute. Wednesday goes. Can we go to Wednesday, gentlemen?
Baron, Tim Crawford wanted to mention that I think on Tuesday evening there might be a chance to see the Lunar X.
No,
So-
yeah, on Wednesday evening.
It's actually Wednesday.
Yeah.
Lunar X, what is that?
The Lunar X is where there's a series of craters they're close to each other, so their rims intersect, and they're higher than the surrounding terrain. So as the Terminator's heading there, as it's becoming dawn, the mountaintops on the ridges get illuminated before the interiors of the craters. And so what you see is it looks like an X along the edge of the Terminator, the moon. And it's south of the center, so down from the center here, like in this picture. This isn't showing the Lunar X, but it shows up down in there, and it'll be showing between 4:45 and 7:10 p.m. will be the best appearance of it.
Now, is that a quarter moon we're looking at, or is that a half a moon we're
It's
looking
your
at?
first quarter, yeah.
First quarter. So in other words, they divide the whole moon, even the part we can't see, into 4 parts. I've often wondered.
Yeah, a
about
quarter of its way through its whole cycle.
Right.
All right, that'll be Wednesday night, the 19th, 12:13 p.m. Daytime will be, let's see, night observing. It's near Pegasus. It's in Leo the Lion. And I have, let's see, the Apennine Mountains. Where are those?
That's, yeah, right there where Tom's cursor is.
That's
Yep.
the Apennines.
Yeah.
We don't have any landers near there, do we? They wouldn't chance it, would they?
But I think Apollo 15 landed near there.
Yeah.
Was that right?
Mhm.
What's a mountain on the moon like? How many, how high is it? It's like a rolling hill, isn't it?
They're really high and spiky because of the less gravity.
Well, they also don't have erosion.
Yeah.
They don't have erosion. Well, that's the old pictures.
Well, they don't have weather erosion, but they do have a bit of erosion from the proton bombardment from the sun.
Oh, yeah, right.
And from meteoric impacts.
Mhm.
And as you can tell, the moon has been hit a lot.
But they want to land on those big mares, those seas, because they're flat, the equivalent of our prairie or a salt flat on Earth.
You know, in my view, that's the big unknown coming up, is how Elon Musk is going to land anything like his Starship on an unknown material, depth unknown, tensile strength unknown, levelness. I would think he'd have to send a robot up first to make a landing pad out of concrete or something.
You mean he's going to ship the housing first and then we?
No, just landing the spacecraft. You know how he has that spaceship that lands?
Yeah, right.
Well, he's going to land on something that has unknown depths of dust, you know, and you don't know how deep the legs are going to sink, and you don't know how tilted it's going to end up. It's really risky.
Yeah, I think so.
Well, we did 6 Apollo landings without that problem. Why
Well,
didn't
they had quite a different system.
Yes.
really?
They had big pads, and they didn't weigh anywhere near as much as the Starship is going to weigh.
Oh, and
But
they're going
they're
to do
also worried about the astronauts sinking into the moon, and they didn't. They went, you know, their boots went in maybe an inch.
and all that flaky dust comes from collisions of incoming meteors, right? That's the only reason we got all the dust.
And it's very abrasive because it has a lot of little spherules of nickel iron in it.
Right. There's
Wow.
no, it has sharp edges and points. There's no wave action in the oceans there to round off the corners.
Well, I remember seeing those animated Disney type pictures of the moon's surface with those spikes you're talking about, but I have yet to see one real, taken by, I don't know, above an orbiter looking down. I guess you're not going to see that, are you?
There's the Lunar X.
Yeah, it's just
Show
all
the Lunar V again. I've never heard of that one.
Lunar V.
Yeah, he's got, see up there, maybe you could magnify that.
What does that mean? Lunar V.
Apparently there's a V shape on the moon.
Oh, okay. The other side that we don't see is really ragged, isn't it? Compared to this relatively smooth half
It
of it.
doesn't have the mares. It has a couple, but they're not near as big.
Do they know why it got so unbalanced like that, our moon?
Well, the side with the mares is where there's lots of stuff that hit it. It may have been the leading edge of the moon initially.
Yeah.
So that it, you know, got more bugs on its windshield. And those things cause mass concentration. So it's a little more massive. And so our tidal forces have kind of pulled that side of the moon to face us.
So those big mares, which look like mares, are solidified, flattened out former lava? Is that what you're saying?
Yeah, and underneath there's big chunks of nickel iron.
But there's no lava inside. It was just pulverized and liquefied.
No, we think it might still have some lava.
I got to tell you, the part that's hard to grasp is a Mars-sized planet, like Jerry was saying, hitting our planet and making the moon. I mean, how in the world?
Well, it splashed out a bunch of vaporized stuff, you know, that eventually congealed.
You definitely wouldn't have want to been here when it happened.
Oh, I guess not.
Urban renewal.
Yeah.
Had to reconfigure a lot of rocks and lava. Can we do Thursday's sky? Venus and Mercury are back in the upper Taurus, the bull. Star clusters M36, M37, and M38 will be visible as if they're normally not.
Those are in Auriga, so they're going to be low, but they're nice.
Yeah.
When are you doing your occultation, Chuck?
It's about 2:30 in the morning Wednesday.
You only do them in the middle of the night, right?
No, some of them are nicely placed.
Okay, but I mean, early in the evening, you got lights that are on and somewhat.
Well, depending on the brightness of the target star, you can get it fairly early.
How many do you do on the average per week?
It's like 13 a month, roughly.
Oh, Is that average for an astronomer like yourself across the country? Everybody doing the same ones, or is everybody doing different ones?
Well, you have to be in the path. So
that's true. I got that down.
Yeah. And I tend to be, I tend to try ones that aren't very likely. Most people get bored with that really quick and stop doing it, but I've had a lot of luck with that.
Wow.
And Whittemore, Murdoch, neither of you have ever wanted to go do that with your telescopes.
No.
No. Chuck's very good at it.
Yeah.
All right.
I've been thinking of it. If you
Have
want
you?
to cover an obscure thing, right at the bottom of the talking points is a comment on 2 obscure catalogs. Everybody
Oh, yeah,
starts their
Caldwell.
own catalogs.
Yeah, they were mentioned last week. What are they again? What's the difference between them?
I took this because we didn't discuss it last week, but there was there's a whole bunch more of these, but the Mellot Catalog,
Okay.
which was started by a British astronomer, published in 1915, to name the catalog the star clusters shown on Franklin Adams chart plates. And then there's the Caldwell Catalog, which was started by Patrick Moore, but he couldn't use Moore because that would look like Messier's name. But he thought because Messier had done all these things that were really to help him pick out comets from the sky, they weren't really a catalog of good sites to look at necessarily. So he made up a catalog of things that he thought Messier should have included in his catalog. And so he also has about 110 of them. And Tom is showing a picture of the Caldwell catalog there.
Oh yeah, I was looking at that at first thinking it was the Messier catalog and going, wait a minute, M45 doesn't look like that.
No.
Well, Messier had how many objects?
Messier also had 110
or
109.
Yeah.
So these are 110 different new ones that Messier couldn't get in his telescope?
No, Messier could have found them. There was no chance of him. These were so distinctive and so bright that there was no chance he could misinterpret these as comets.
So anything but a star. Is that a good definition? Do we see any stars? Are those all
in the Messier catalog, there is one double star that he thought there was nebulosity around.
Yeah.
All right.
And another thing he did here is he included southern hemisphere objects that Messier couldn't see.
Right.
Can you order these catalogs? Or are you going to, Jerry?
No.
No, you just look them up online.
Oh, that's the way the catalogs are done today. Okay.
I like the new general catalog, NGC.
Yeah.
It was new in 1885.
Yeah.
It's
But
got
it's
what,
the-
7,500 objects in it.
Yeah.
Do they still make the whole Earth catalog? That was my favorite.
Well,
I
we
gotta
got NGC 457. That's the owl cluster.
Caldwell objects. That's the name of the astronomer. And these are stars and nebula and God knows everything in the heavens. What are we looking at, Totten? Do you know?
That's a star map of the whole sky and showing where the Caldwell objects are.
And
That's
the blue is the Milky Way.
Milky Way.
The blue is the
When we were at Rio Condo or the Vista Point, Milky Way finally rose well after midnight. It was kind of neat because it was parallel to the horizon.
Yeah.
And it came up overhead.
And you can see the large and small clouds of Magellan down there too in the lower right.
Did the ancients delineate? Did they know they were dealing with different things, or did they just call it all stars? Just heavenly bodies.
Planets.
Well, did they know difference between a planet and a star? They didn't, did they? They were just bright.
Planet means wanderer. Planets were things that moved.
Oh, okay. The way they move. That's all right. But Messier didn't know some of these things were out of our galaxy, weren't they? A lot of them were in the galaxy. Star clusters, for example, nebula.
Right. He just knew they were fuzzies.
Right. That wasn't made distinct until Hubble did it in the 1920s.
Well, listen, gentlemen, speaking of Hubble, the 3 pictures of Jupiter, the images that are photographed, different light frequencies, infrared, visible, and ultraviolet. the visible and ultraviolet taken by the Hubble and the infrared taken by the NIRI Instrument Observatory in Hawaii.
Yeah.
Did you see those pictures?
Yes.
The difference, we can see Jupiter that clear that we can get a heat. There it
Yes.
is. Heat
Yeah.
signal off of it. And my question would be the one on the right, the ultraviolet. What does that mean? Do we have ultraviolet glasses? The military has infrared to see heat in the dark, but
You
what do you do?
can put filters on that show any of these bands of light, selectively selective bands. You can have a blue filter or a red filter or an ultraviolet filter or infrared filters. The infrared filter has to be cooled in order to be effective because the filter emits infrared light. But you can see that on the left, the infrared, you can see that Jupiter is glowing inside the clouds. The Jupiter is actually heat or hotter. Like Neptune, it gives out more light than it receives from the sun. It's still got heat in it from its gravitational collapse when it formed, but its internal heat never reached the 10 million degrees necessary to start fusion of hydrogen. Otherwise, it would have turned into a star. So it just stays this hot planet. The visible, yeah, go ahead. But anyway, these different spectral bands give you information on the chemical compositions.
But the middle picture is supposedly how it looks to us with our regular eyes.
Yes.
Like looking down from the Juno spacecraft. And on the right, what does that mean, ultraviolet?
Oh, it's a higher energy band than visible. It is, you can see that the great red spot and the little red spot both absorb ultraviolet. They're not reflecting any back because the ultraviolet here comes from the sun. It's not generated internally.
Although there's some ultraviolet, you'll sometimes see auroras on Jupiter.
Yeah. Oh, yeah. Yeah.
Oh, especially at the poles, right?
Yeah.
Yeah.
Do we have pictures of it?
Yeah.
Yes.
Not here, but there are pictures of it.
And they had to use Hubble to do the ultraviolet because most of this would not come through our atmosphere.
Yeah.
Oh, okay. Well, how about a nice Juno picture? That's the name of our orbiter. And is anybody keeping track of that? It's what, every 50 days or something it passes by?
I believe Juno has taken pictures of the auroras on Jupiter.
Yeah, it's doing the top and bottom. The polar regions are really weird. They're just big cesspools of colors and
very chaotic storms.
Paisley ties.
I think we're down to the wire. Anybody want to close out with something special they want to share with the world? Astronomical or otherwise? We're looking
well, the
forward to
Arlington is opening up for movies this coming weekend with
what is?
Theater Pipe Organ. The Arlington Theater is opening up for movies, and the Great Theater Pipe Organ of the Arlington will be played.
You expecting a good crowd?
I don't know. Well, they're limiting the audience to 200 people.
Okay, in the Arlington.
Because they got to sit 6 feet apart and all that other stuff.
Of course. Well, maybe we'll show up. It's $5, right?
Right.
Sounds good to me. I love a good old-fashioned movie, anything. Is the popcorn going to be served in the lobby? That's important too.
Popcorn is free.
Oh, with your $5. All right. And then
that would get you about 5 kernels of popcorn.
And then tomorrow night we have the telescope workshop. What are we doing on that, Tom? Are we building something?
I'm just listening in. But
a
lot of folks, a lot of astrophotography by the folks, and then talking about how they're modifying their telescopes, and then Tim is continuing to work on an 8-inch mirror to get that perfected. And so there's lots of little topics that come up. It's very interesting to me.
All right. So start with SBAU.org or go to SB Astro Unit channel on YouTube, and we'll do this again for number 13 next week. Gentlemen, stay safe. Stay with your lovely lives.
Bye.
We'll see you
Okay.
next
Thanks, Tom. Thanks,
Ron.
John.
Thank you.
Thanks, everybody.
All right. Bye-bye, everybody.